Hello everyone. Today we are going to deal on writing molecular formula correctly. How the different molecular formula of different compounds can be written correctly. Let us go with that without any delay. So for this, I would like to take you with some examples. At first, let us take the reference of calcium chloride. The very first step is that you need to write the symbols or the formula of the radicals that are associated. Calcium has the symbol Ca and chloride has Cl. On the top of these both, now you need to write the respective valencies of those components. Calcium has valency 2, whereas chloride has valency 1. This is what the particular idea you need to have in advance. After this, just exchange the valencies between these two different components associated, forming the molecule. Now write down the particular components with exchanged valencies. Ca1, Cl2 is what you get. However, one is not to be written. That's why finally you write it avoiding the number 1. That gives the formula CaCl2, which is the final formula of calcium chloride. Likewise, let us move on to the next example. Magnesium carbonate. Magnesium has the symbol Mg and carbonate is the radical with formula CO3. That is, both magnesium and carbonate, they have valency 2. Now the next step is that you will exchange the valencies between these two different components. The valency of the left component goes to the right component and the valency of the right component goes to the left. However, provided that if it is a radical containing group of atoms, such as in this case this is carbonate with 1 carbon atom and 3 oxygen atoms, this is the group of 4 atoms. Now what you need to do is that you need to write it while exchanging the valencies, the particular radical inside bracket, and outside that only the exchanged valency you have to write. And something next you need to consider is that out of these exchanged valencies, if they can be cancelled between each other, then we can reduce them to the lowest possible term. Here both of these are 2, that's why they cancel each other. And finally there is nothing outside CO3 which is kept inside bracket. Here nothing means at least there is 1. So that can be avoided and simply directly the formula can be written without bracket, that is MgCO3. That is the final molecular formula of magnesium chloride. That is the final molecular formula of magnesium carbonate. Now let us move on to carbon dioxide. Here carbon dioxide involves the combination of carbon and oxygen, or the oxide radical, let's say. We can Carbon has valency 4 and oxygen has valency 2. Now these two different valencies are exchanged between each other. That gives C2O4 in the next step. Now taking 2 as common, what you can do is that you can write it as C1O2 inside bracket as shown. The common component, the common factor can be removed, and that's why finally you can write avoiding even the number 1 in the upper step. Final formula for carbon dioxide becomes CO2. Now please try with the following molecular formula: potassium chloride, magnesium chloride, zinc chloride, and water, that is hydrogen oxide. Take some time pausing the video before you get the answer of these all. Now please check your answers. Potassium chloride can be written as KCl, for which the steps, the criss-cross method to be followed are as given. So potassium has symbol K, chloride has Cl, the symbol, and the valencies of both of these are 1, that are exchanged, giving K1Cl1, and 1 doesn't need to be written, so simply we write KCl. Now let us move on to magnesium chloride. Magnesium is the element with valency 2 and chloride is the radical with valency 1. That is, the valencies are written on the top of each. Now the valencies are exchanged between each other and we get Mg1Cl2 as shown. Now 1 doesn't need to be written, so the final formula for magnesium chloride is MgCl2. I hope you understand and have done correctly. The next one is zinc chloride. First of all, zinc has the symbol Zn. Chloride is the radical that has the symbol Cl. Now, writing the valency of both of these on the top of their symbols and exchanging them between each other gives Zn1Cl2. And 1 is not to be written. That's why the final formula of zinc chloride is ZnCl2 and so on. I hope you have done it correctly. Now let us move on to water, that is hydrogen oxide, for your reference. So hydrogen has symbol H and oxide has O. Now the valencies of these are written on the top of each as shown and exchanged between each other. And we get S2O1. And as usual, we don't need to write 1. That's why S2O is the final molecular formula for water. This is how the molecular formula of water is formed as S2O. Now, please try again the next step with these 4 different components: calcium oxide, magnesium oxide, sodium oxide, and sodium carbonate. Pause the video for a while before you proceed. Now, let us check how you have done, whether it is done correctly or not. First of all, calcium oxide. The symbols for calcium is Ca, and for oxide radical, the symbol is O. Both of these have valency 2 that need to be exchanged between each other, that finally gives us the structure Ca2O2. And again, the common exchanged values from the exchanged valencies can be reduced to lowest term. That's why these two get cancelled each other. Or simply you can understand that 2 is taken common and removed, such that inside bracket, while taking common, you have got it Ca1O1, and directly the final formula will be CaO for calcium oxide. Next one is magnesium oxide, and for magnesium oxide, the symbol of magnesium is Mg, and for oxide radical, it's O. The valencies are written on the top of these symbols, Mg and O. Both are 2, the valencies, and now they are exchanged. Again, these valencies, they get cancelled between each other. You can even cancel it here, or you can take common this way as shown. And finally, the formula for magnesium oxide is MgO. Let's move on for sodium oxide. Sodium has symbol Na and oxide has O. And the valencies of these are 1 and 2 respectively. Now these are exchanged such that the structure we get in this symbolic representation is Na2O1, and 1 doesn't need to be written. That's why the final molecular formula for sodium oxide is Na2O. Finally, for sodium carbonate, let us move ahead. Sodium has the symbol Na and carbonate radical has CO3, the formula. The valency of these are Na has valency 1 and carbonate has valency 2. Now these are exchanged between each other, but again remember here CO3 is a group of atoms. So while exchanging the valency for CO3, you have to keep CO3 inside bracket. So Na2 bracket open, CO3 bracket close, and outside the bracket you have to write 1, the exchanged valency. And again 1 doesn't have the meaning, that's why you can avoid this 1 in the next step. And as you remove 1, the bracket has no meaning, that's why directly you can write Na2CO3 as the final formula for sodium carbonate. I hope that you have done these all correctly. Sodium bicarbonate, calcium bicarbonate, calcium sulfate, magnesium carbonate, zinc chloride, and ferric chloride. Please try and Write your answers as the comment in the comment box below, and we will see if you have done it correctly. Thank you.